The embryogenesis and the age-related degenerative alterations of the lens justify the difficulties that we are up against when we deal with a hard nucleus. On the 25th day of embryonic evolution, two mesencephalon evaginations form the optic galls. They keep on expanding, and on the following day, they come in contact with the cutaneous ectoderma. On the 30th evolution day, an invagination of this ectoderma inward the optical dome and form two lens galls, which detach from the cutaneous ectodermic epithelium that it originated. Now let's focus on one optic gall and on the alterations that will take place in the epithelial cells which covers up the inside. At the end of the 6th week, the cells on the posterior wall of the lens optic gall stretch until they reach the anterior wall, turning into fibers. These primary fibers constitute the so-called embryonic nucleus of the lens. The anterior cells of the lens remains morphologically unaltered. On the 8th week, the epithelium cells of the lens equator begin to divide itself, and its stretched daughter cells turn into secondary fibers of the lens that are simultaneously added to the surroundings of the embryonic nucleus. On the 3rd month, it is possible to distinguish the fetal nucleus. On the site of the junctions of these fibers, Y sutures are made. After this period, the sequential deposition of fibers around the fetal nucleus will determine the adult nucleus. After birth, the lens will present few quality modifications, but it will continue to increase significantly in size due to the fact that new cells are produced and turned into fibers. With aging, the lens degenerative process is more remarkable in the posterior pole. This area is farther from the main feeding source of the lens, the aqueous. These two factors, the distribution of the nuclear fibers and the